In this video, we're going to talk about antiderivatives of polynomials. This is just putting together a couple of things that we've learned so far, and so we're just going to see a couple of examples. Let's get right to it. For our first example, let's warm up by finding an antiderivative for the function f of x is equal to x squared plus 2. So our notation for antiderivative is going to be this funny s sign, x squared plus 2, and then we write dx. Alright, so I know that the antiderivative of a sum is the sum of the antiderivatives, so I take the antiderivative of x squared, and I take the antiderivative of 2. We learned about the power rule, so what I'm getting here is 1/3 x cubed from this x squared, and what I'm getting from this 2 is just 2x, and then I always remember to put plus some constant at the end. I check my work, in this case, by taking the derivative. And if I differentiate 1/3 x cubed, I get 1/3 times 3x squared. And if I differentiate 2x, I get 2. And if I differentiate c, I get 0. So cleaning this up, the 1/3 and the 3 cancel, and I end up with x squared plus 2 plus 0, which was exactly the function that I started with. So, feeling good about that. Our second example is a little more difficult, just because it has more terms, a couple of coefficients on the front. We want to find an antiderivative for the function f of x is equal to 2x cubed minus 4x squared plus 7x minus 1. So, antiderivative of 2x cubed minus 4x squared plus 7x minus 1. Again, I know that the antiderivative of a sum is a sum of the antiderivatives, and I also know that if I have a constant, I can factor it out. So what I'm getting here is I take the antiderivative of 2x cubed. Well, that 2 can just kind of sit there, and then the derivative of x cubed is 1/4 x to the 4th power. Next, I have minus 4, and the antiderivative of x squared, which is 1/3 x cubed. The antiderivative of 7x is 7 times 1/2 x squared, and then the antiderivative of 1 is minus 1 times x, and as always, we have our ultra important plus a constant. So I could clean this up a little bit. 2 times 1/4 is 1/2 x to the 4th power minus 4/3 x cubed plus 7/2 x squared minus x plus our constant, right? As usual, I sort of think about anti-differentiation as kicking the power up 1, where differentiation kicks the power down 1, except in this case I always have to divide by whatever the power is going to be. So I have 1/4 x to the 4th power coming from x cubed, so the exponent goes up by 1 and I divide by the new exponent. So I have 1/4 x to the 4th, same here, exponent goes up by 1 to 3 and I divide by 3. Exponent goes up to 2, I divide by 2. Exponent goes up to 1 and I divide by 1. Okay, that's not a big deal. And then I have my constant. As usual, I would like to check my work by differentiating. So I have 1/2 times 4x cubed minus 4/3 times 3x squared plus 7/2 times 2x minus 1 plus 0, of course, from the constant. And working out this 4 times 1/2 is 2x cubed. 4/3 times 3, the 3's cancel, minus 4x squared. These 2's cancel, plus 7x minus 1, and that is indeed the function that we started with. Ramping up the difficulty again for example 3, this time we want to find an antiderivative for the function f of x is equal to negative 147x to the 256th power plus 281x to the 173rd power plus 3x to the 15th power plus 10. So I take the antiderivative, negative 147x to the 256th plus 281x to the 173rd plus 3x to the 15th plus 10. And what do I get? Well, negative 147, we're getting pretty good at this by now, 1 over, add 1 to the exponent, 257x to the 257th plus 281, 1 over x. The exponent is going up to 174, x to the 174th, plus 3 times 1 over exponent is going up to 16, x to the 16th, plus 10x, plus our constant, which just barely fits on the end of the page there. So cleaning this up, I have negative 147 over 257, x to the 257th, plus 281 over 174, x to the 174th, plus 3/16, x to the 16, plus 10x, plus my constant. This one I leave to you to check, partially because I want to give you something to work on, and second because it's actually pretty easy in this case since we haven't done a whole lot of simplification. So maybe you can even see how differentiating would give you the right answer just from the example we just did in example 2. So again, the important thing to remember is that the constants factor out, and then we always divide by what the exponent is going up to in the case of just x to some power. I hope you're starting to get a good feeling of how to take antiderivatives for certain types of functions, particularly polynomials. Keep on practicing. Make sure you do a lot of practice problems on this topic because you'll need it for the rest of the course. Good luck!